All right, looks like we can get started. Good evening, everyone. My name is Dr. Damien, and I'm the host for this talk, along with my friend here, Himansu Patel. And today we're glad to see all of you attend. As you know, COVID has been raging, and today is the second meeting we're having in person. Last one was quite well attended, so maybe people might still come. But in any case, based on the time we have now, I think we can get started. So first of all, I'd like to give a shout out to all our sponsors. First is Improving. They give us the building, the pizza, and everything we need to be here. And then also Cloud Tech Experts. We do mostly cloud native training and Docker, Kubernetes, this kind of things is what we do. And recently, Morpheus Data, they just joined us as well. So we're glad to have them as a regular sponsor for this meetup. Today we have a very good lineup. There's going to be two speakers. And we'll start with our first presenter, Marcel Reed. He's online. And again, this is the first time we have someone present to us remotely. So hopefully it goes well. So far, I think he's quite comfortable. So we're just looking forward to introducing. So without wasting much time, I'm going to introduce myself. He will introduce himself when he comes to speak. And at the same time, we have some of his colleagues here. And maybe when it's time, maybe you can also introduce yourself to the group. All right, so let me hand over to our first speaker, Marcel Reed, and then after that, we'll have our second speaker. All right, enjoy.
All right, thanks, Damien. All right, so hopefully everyone can hear me very well and see me as well. So as Damien mentioned, this particular session is going to be bridging the gap between Kubernetes and non-Kubernetes workloads. So I am Martez Reed, Director of Technical Marketing with Morpheus Data. I have about 15 years of IT experience. Probably about the last 8 to 10 years have been very much focused on automation and orchestration. Can be found on LinkedIn, Twitter, as well as GitHub. This particular session, we're going to walk through some of the challenges of hybrid cloud environments, hybrid service mesh, as well as hybrid secrets management, and how those two aspects continue to help us bridge the gap between the Kubernetes workloads and the non-Kubernetes workloads. So one of the big dreams as it relates to, let me make sure my screen is sharing.
One second.
All right, we got the screen share going. All right, perfect. I'll repeat exactly everything I just said. Bridging the gap between Kubernetes and non-Kubernetes workloads. I am Martez Reed, Director of Technical Marketing with Morpheus Data. You can find me on LinkedIn, Twitter, as well as GitHub. This particular session, we're going to walk through some of the challenges of hybrid cloud environments, how hybrid service mesh, as well as secrets management play a factor in actually enabling hybrid cloud IT. And we'll walk through what those actually look like from a technical standpoint. So one of the dreams of tech is, and really, and a lot of people will tell you it's the future of where technology is heading and that the IT landscape is headed, is Kubernetes being the path forward for most organizations as it relates to future application development and where they're going to place their applications moving forward into the future. And so for a number of organizations, that's the desire, and a number of organizations will be able to accomplish that capability as it relates to where they place workloads, as well as how they develop applications. But there's always a but. In the case of IT, most organizations, particularly those of enterprise size, have various workloads that already exist, as well as are going to exist in the future that may not be put into Kubernetes. And so that's the reality of technology, is that there's, in addition to Kubernetes, there's going to be virtual machines that stick around for quite some time, much like we see now with mainframes and bare metal. Those have lived for years and years and years and will continue to stick around. In addition to that, we have things like serverless. Seemed like it was a fad a number of years ago, but certainly there are a number of major use cases for it, whether it be on the application side or whether it is things like management and security for cloud environments. In addition to that, you have cloud native services, things like object storage, database as a service, queues as a service, various capabilities that provide functionality from a managed service perspective that organizations want to take advantage of. And so we have a large set of technologies, capabilities, components, and oftentimes vendors that provide software capabilities to enterprise organizations. And one of the challenges from a management perspective is finding a way to be able to manage all of these components and technologies in the environment without being burdened by the challenges and the management overhead. So certainly one of the things that adds additional complexities from a capability standpoint. So the question becomes, we talk about bridging the gap. How can we start to look at ways in which we're going to bridge the gap between Kubernetes workloads, which is where a lot of organizations want to head, where all of their applications are running in Kubernetes and everything is based on Kubernetes, interacts with Kubernetes. The challenge becomes, as I mentioned, other workloads are going to continue to exist, either those that have previously been built or those that will actually be built in the future for specific use cases, whether it be in a virtual machine from a security isolation standpoint, or it being a commercial off-the-shelf application that is only available in a virtual machine format, or scenarios where bare metal deployments make sense from a capability standpoint, whether it be something like having direct access to the hardware for things like GPU access, or whether it is a performance reason in which the organization decides the application or the component should run on bare metal servers. And so we're in this world where there's always going to be things that aren't running in Kubernetes. How do we get to a situation or scenario where we can have a meaningful integration or interaction between Kubernetes workloads and non-Kubernetes workloads? And so a number of areas that I've highlighted here are some key aspects of components or integrations that I think help bridge that gap. So one of the first ones being network security. There's always the question of security, and in particular from network security standpoint, the nuance of Kubernetes workloads interacting or connecting to non-Kubernetes workloads ratchets up from a complexity standpoint. And so we'll delve into the specifics of what that looks like. Federated workload identity. So the idea of being able to assign an identity to individual workloads and then be able to use that same identity to interact with workloads that sit or reside on different systems and also will honor that identity from the system. Secrets management, being able to manage and maintain credentials, API keys, SSH keys, all these things are extremely important, especially as we talk about some of the complexities and challenges that we continually face as an industry in terms of securing workloads that are mission critical and contain the utmost sensitive data. And then finally, looking at ways in which we can leverage automation and orchestration to help effectively glue or stitch these things together from a capability standpoint. And so now let's unpack a few of these particular items to see how we can actually leverage the technologies that exist now, as well as what that might look like from a management paradigm moving into the future to integrate these two scenarios or situations of Kubernetes workloads and non-Kubernetes workloads. So one of the things that we talked about was the idea of network security. And so as we look at what traditional network communication looks like, typically it is one service that looks to interact with another service. In this particular example, we have a Golang application that wants to connect to a PostgreSQL database. And so really all that happens is there's a need for traffic from the application to go to the database, whether that be to perform something like a read or a write or an update to the database. Irregardless of that, there needs to be network communication that enables that particular operation to be successful from a network layer standpoint. And so that's traditionally what network communication looks like. So as we start to build upon that, from a Kubernetes perspective, inside a single cluster, communication looks very similar to what we just saw, in which the application wants to talk to the database. In this case, there's a level of simplification as it relates to the networking aspects of that communication. And so the way it works is the application wants to talk to the database. It utilizes the IP address that it found based upon a DNS lookup and proceeds to talk to the database. And so in all Kubernetes world, keeping it simple from a single cluster standpoint, this is fairly straightforward, makes total sense, aligns exactly with what we've always done and always known from a communication or networking standpoint. So the question then becomes, we're focused on how do we integrate or facilitate the interaction between Kubernetes and non-Kubernetes workloads. And so in this particular example, we have two applications running in our Kubernetes cluster. We have a Golang application as well as a Python application, both running in the cluster. And for simplicity purposes, the cluster has been assigned an IP address from an outbound communication perspective of 10.0.0.10 in order to be able to communicate or interact with the broader IT environment, utilizing standard networking capabilities in terms of switching packets in this case. And so Python application wants to communicate or interact with the Oracle database. In this case, it's 10.0.0.11. So it sends a packet indicating the server that it wants to interact with, or in this case, the IP address that it wants to interact with, and then successfully creates that connection, assuming that it has the appropriate credentials to facilitate that connection. Simple, easy enough, follows exactly the traditional models that we've always known and loved. Then we have the Golang application. It wants to access the Postgres database. It does that utilizing the IP address of 10.0.0.12 and communicates with the database. And so from a networking standpoint, seems simple enough, fairly straightforward. But when we start talking about the security aspects, one of the things that we'll notice on this particular slide is that both forms of communication or both transactions, the source IP address is actually the same for both the Python application as well as the Golang application. And so from a traditional networking security standpoint, this creates somewhat of a problem in the sense that I can't independently identify the IP address that an application is coming from. And so as an example, if I wanted to restrict access or prevent access from the Golang application accessing the Oracle database, I have no real good way to do this because typically from a firewalling perspective, the manner in which the restriction is applied is based upon source information. In this case, it would have been the IP address. So I would have made the assumption that the IP address for the Python application is how I want to restrict access to the Oracle database. Yes, there are certainly aspects or additional ways that I could facilitate this, whether it be from a Kubernetes cluster standpoint, utilizing something like network policies to restrict the egress access. So in essence, within the Kubernetes cluster, prevent the Python application, or in this case, the Golang application, from accessing the IP address of the Oracle database, which is 10.0.0.11. So I could do that, do that to restrict that access. The challenge with that becomes, what's my ability to be able to manage that at scale? So that's where it starts to become a very difficult problem, in which, once again, we're still leveraging more static identifiers to facilitate these operations, and also starts to diverge away from the management paradigms that are native to Kubernetes, as well as those that have been utilized in a bare metal or virtual machine standpoint, and being able to tie the two together from a management perspective. That is one of the challenges that organizations that have hybrid environments typically face, is being able to manage these specific aspects, whether it be multi-cloud in the sense of multiple cloud providers, whether it's AWS, Azure, GCP, or in scenarios where we're talking about hybrid cloud, of integrating on-prem with public cloud, or very specifically in this case, simply just integrating different computing models, Kubernetes and non-Kubernetes workloads. And so we're presented with a challenge of, how do we restrict that access to prevent applications accessing services that they're not intended to access, over and above simply relying upon authentication to ensure that a service does not have access to another service in which it should not. And so that's where we're presented with the construct of service mesh. And so many that have dealt with Kubernetes already are, I'm sure, quite oftentimes pretty familiar with at least what a service mesh is, or at a high level have heard about service meshes. So for those that aren't fully aware of service meshes, Wikipedia's definition for a service mesh is a dedicated infrastructure layer for facilitating service-to-service communication between microservices. So one of the things that we quickly see, even from this definition, is the service-to-service communication, which is what we just walked through from a networking standpoint. I want one service to communicate with another service or interact with another service. In this case, it wasn't a microservice architecture, but certainly still is applicable. In addition to the high-level definition of service mesh, typically certain features or capabilities are offered by service meshes that are very appealing. One of them being service discovery, or the idea or ability to be able to move away from traditional IP addressing, in the sense that the manner in which I assign addresses to my servers or my workloads is statically assigned, and that is a fixed piece of metadata that is not going to change. And based upon that fixed piece of metadata, I make the assumption that the IP address for my database server is always going to be 10.0.0.11 or whatever it might be, and make assumptions based upon that. But in a more ephemeral world where workloads will come and go, that idea or that construct or management paradigm starts to fall apart pretty quickly, because if a server or service is .11 at one point in time, and then all of a sudden the next time I see it, it's .53, then the idea of associating a service to a fixed piece of metadata or IP address in this case starts to fall apart. And so, similar to the benefits we receive from DNS, service discovery allows us to leverage a similar mechanism or paradigm as it relates to managing workloads, in that more often than not, essentially the workload registers itself with the updated information of where it can be located. Traffic management is another big capability that a number of organizations are looking at from a service mesh standpoint. So the idea of being able to do things like traffic splitting, in which I want to send a portion of traffic to version 1 of my service, and then another portion of traffic to version 2 of my service, to start doing things like A/B testing, starts to really simplify things like blue-green deployments, really opens or unlocks a number of capabilities that were traditionally available via the load balancers, but oftentimes was a little bit more difficult to facilitate from an automated end-to-end standpoint. In addition to that, you have things like network observability. So being able to get deep and rich insights into the application's behavior based upon the actual network traffic. So being able to do things like dependency mapping and being able to do a level of tracing based upon the network communication between services. Mutual TLS is another one. So being able to secure the communication between services, but also being able to use that or leverage that for a form of authentication or authorization from a workload perspective. And one of the other interesting ones is fault injection. Chaos engineering is a pretty big construct now. It's definitely gaining traction. You look at a number of the players in the space, whether it be organizations like Gremlin, have really started to bring chaos engineering to the forefront. And so being able to leverage the service mesh to inject faults at a network level standpoint. So doing things like being able to slow down traffic communication to simulate saturation of a network link, or being able to do things like purposefully drop packets to see how the application or the service is going to respond from packets being dropped. It's certainly another one of the capabilities. And on this particular slide, we have a number of the key players in the space. And in this case, specifically, those that offer a hybrid capability. And so what I mean by that is service mesh projects or products that allow organizations or users to be able to use Kubernetes as a computing method to connect to the service mesh, but also bare metal and virtual machines can also integrate with the service mesh. So another one of the major players in the service mesh space is Linkerd. It is not on this particular slide because Linkerd only supports Kubernetes. And so in this particular context, we want to be able to integrate or add our virtual machines and our bare metal instances into the service mesh to take advantage of a number of the benefits that we've listed here, but also be able to, as we look from a security standpoint, also be able to easily facilitate that network security utilizing a different form of identity outside of just IP addresses and MAC addresses. So Istio is certainly one of the major players. Kuma, which is created by an open source project created by Kong, which is typically known as the company that creates the API gateway. And then finally, HashiCorp's Console. So 3 major players or 3 major projects or products that exist in the space to be able to provide or facilitate hybrid service mesh, as I term it. So for those that aren't familiar with service mesh, how does it work? And so that's what we're going to walk through pretty quickly, just to get a sense of how all the pieces fit together and how everything works. From a traditional standpoint, we saw that from a Kubernetes standpoint, the application was going to talk to the database. It's going to use standard networking constructs to facilitate that operation. But from a service mesh standpoint, typically what's going to happen is in the case of Kubernetes, a sidecar is going to be injected into the pod. Essentially, what's going to happen is another container is going to start running in the same namespace as my applications, in this case, the Golang application and the PostgreSQL database, to provide the benefits and capabilities that we saw from a service mesh standpoint. And so traditionally, what would happen is the application would talk directly to the database via the network. But what's going to happen in the case of the service mesh is that the Golang application is not going to talk directly to my PostgreSQL database. It's going to actually talk to a network proxy that is actually running in that sidecar that we injected. So it's not going to be direct communication. It's going to talk to the proxy. And then what's going to happen is the proxy, in this particular case, that resides in the same pod as the Golang application, is going to talk to, in this case, its peer that resides in the same pod as my database. And so that's how the communication is being facilitated. And then ultimately what's going to happen is the agent, which is also running a proxy, is going to relay that communication to the PostgreSQL database. And so what we're seeing is a pretty wild divergence from what we saw previously, which was application talks directly to the database. And now what we've done is introduced effectively intermediary proxies to handle the handoff between the application and the database. And so what this does is starts to unlock that capability that we looked at and saw from a network security standpoint, a fault injection standpoint, a traffic shaping standpoint, in which what we've done is we've inserted a component into the data plane to then handle what's done with the traffic itself. And so the manner in which we could start to leverage this starts to unlock many of those things that we saw from the previous slide, but also helps us address the network security constructs that we look at, in which we could no longer start to quarantine or close off communication based upon an IP address. In the case of inter-Kubernetes cluster communication, we had other constructs that could facilitate that pretty easily. But as more and more organizations adapt to Kubernetes and start to look at service mesh as a reason or as a enabler of adopting those other mechanisms or other features like the mutual TLS, like the traffic shaping, there's a benefit that comes along with it for non-Kubernetes workloads. And we'll look at that in a second. But as we finish walking through this particular scenario, we have the HashiCorp console server, which acts as a control plane in this particular example. And what it does is it actually hands out or relays the proxy configuration to the proxies that are running as sidecars in this particular Kubernetes cluster. And so what we've done is created a control plane and a data plane. The data plane sits, the agents or the proxies sit in the data plane, intercept the network communication, and provide the capabilities that we saw. And the control plane handles the actual communication with the agents to perform the given operations that are desired in terms of network traffic management, mutual TLS, all those benefits that we saw. And so this is great from a pure Kubernetes perspective. And tools or projects or platforms like Linkerd could accomplish this from a pure Kubernetes standpoint. A number of the others provide that same capability. But what we're looking at is being able to bridge the gap between Kubernetes workloads and non-Kubernetes workloads. And so the next slide, what we see is actually very little has actually changed. So from a hybrid standpoint, in order to be able to take advantage of a number of the same benefits, but also allow us to perform network security at an identity level, all that's changed is that instead of the HashiCorp console agent in this example running as a Kubernetes sidecar container, it's simply running as a service on my Linux virtual machine. And so that's enabled me to take advantage of the same capabilities we saw the service mesh provide from a Kubernetes standpoint, but also enables us to perform the firewalling at an identity level in which I can specify, if we went back to our example, I only want the Golang application to talk to the PostgreSQL database. I can specify that particular configuration utilizing the service mesh. I tell the service mesh, in this case of HashiCorp console, that my intention is that you are only allowed to talk to the PostgreSQL database. Similarly, with the Python application, I can specify that it should only talk to the Oracle database. And so we've started to take advantage and bridge that gap of no longer having to think about, well, do I need to allow the entire Kubernetes cluster access to this block of IP addresses in my quote unquote legacy environment to get access to my bare metal instances and my virtual machines? No, what we can start to do is we can start to bring those applications or those services into the service mesh to take advantage and the benefit of the same capabilities that are being provided to Kubernetes, but outside of Kubernetes. The other thing of major importance is constructs like secrets management. And so I'm going to touch on service mesh, going to touch on secrets management. Those are a number of the major areas that the IT industry is looking at in terms of how do we move to a more secure security posture for our applications as well as our IT environments. And so in this particular case, a couple examples here, but secrets management being the idea of secure storage for sensitive data, such as passwords, API keys, or encryption keys. And so a number of things I've listed here from a capability standpoint. Ideally, at minimum, I just need a place to store my sensitive data. My credentials, how is my application going to access the database? Ideally, I could store it somewhere securely, and as the application needs it, it fetches it. In that case, we're talking about secure credential storage. I have the secret, I put it somewhere securely. One of the things that HashiCorp Vault offers, and is certainly one of the major reasons why a number of people have gone to HashiCorp Vault or look to adopt HashiCorp Vault, as well as why organizations are adopting it, are things like, from a feature standpoint, dynamic credential generation. So being able to utilize the concept of short-lived credentials in the case of whether it be access to public clouds like AWS, Azure, GCP, or being able to use that from an application access standpoint to services like databases or RabbitMQ clusters, various different services that are available, and being able to simply utilize short-lived credentials as opposed to the static credentials that have been traditionally utilized. And so as we talk about bridging the gap in Kubernetes, a number of those constructs are natively there. When we start talking about 12-factor applications and some of the new paradigms that are being leveraged in order to facilitate those things, that still translates to non-Kubernetes workloads. So really, how can we start to leverage some of the practices and the capabilities that Kubernetes offers and provides natively and bring those into what we're doing from a non-Kubernetes workload perspective to get a leveled layer of management across both models. And so from a dynamic credentials standpoint, one of the ways we can facilitate this is utilizing a number of the constructs in this example that HashiCorp Vault provides to be able to facilitate dynamic database credential access to our database. So in this example, there is a Kubernetes sidecar being injected into our Kubernetes pod that runs our application. And what it's doing is allowing us to facilitate that interaction between the workload itself and the Vault cluster. And so what's going to happen is what we want is that our database credentials are injected and available to our application, whether that be something like making them available on a volume or injecting them into environment variables. At the end of the day, we want to be able to get access to the credentials. And so that can be facilitated by, as I mentioned, utilizing that sidecar, interacting with the HashiCorp Vault cluster, and then HashiCorp Vault actually interacting with our PostgreSQL database to generate short-lived credentials. In the case of the database, it may be something like 7 days is the least, or maybe 14 days, something that provides us an assurance that it's not going to be changing every single day or every couple of hours, but also something that is short enough to give us the reassurance of if something were to happen to those credentials at some reasonable point in time, those credentials would get rotated and the previous credentials no longer be valid. And so once those credentials are generated, they're going to be passed or handed off to the Vault agent or the Vault interaction component for our application and present those to the application, at which point the application then can connect to the database utilizing the appropriate means of authentication. And so this provides a number of great capabilities, both for Kubernetes to Kubernetes workloads, as well as Kubernetes to non-Kubernetes workloads. And so once we start to look at the capabilities both of these offer or provide, we can start to look at if we were to layer both of these together, what we would get is a means of secure capability in terms of interaction and integration between our Kubernetes workloads and our non-Kubernetes workloads. In this particular example, we've got the application running in a Kubernetes pod talking to a database that resides in VMware vSphere. And so what I've now done is I've addressed the security from a network standpoint, utilizing the service mesh, in this particular case, HashiCorp console, to ensure that my application can only talk to the services, or in this case, service that it is intended to, and not be able to interact or talk to other services that it's not authorized to from a network standpoint, utilizing a native constructor capability from identity standpoint, as well as being able to utilize secrets management from a database authentication standpoint, utilizing short-lived credentials. So now my application is both secure from a network standpoint, as well as secure from an identity or authentication standpoint, utilizing short-lived credentials. So we've walked through how to facilitate this from a service mesh standpoint and how the networking works and the integration takes place, but also looked at from an authentication standpoint and integrating the application to the database. And so now one of the things is we talked about integrating the two. From a Kubernetes perspective, most of these things are fairly straightforward. I'll say fairly straightforward. There's definitely some nuance and complexity there. But in terms of actually facilitating things like the secure secrets management with HashiCorp Vault, as well as the service mesh capability, things like the service mesh capability, oftentimes it's adding a single line or a set of lines in your YAML that specifies what specific configuration that you want to take place. And then it's integrated with the service mesh. The sidecar is automatically injected. You don't have to think much about it. Similarly with the HashiCorp Vault integration. Really, really easy, really straightforward in most cases outside of the specific nuance. When you start to talk about integrating non-Kubernetes workloads with the Kubernetes workloads, that level of complexity, as well as ease of deployment and configuration, starts to get out of hand in a lot of cases. And so in this particular case, we have an example of what that orchestration might look like. And so utilizing a capability, platform like Morpheus, certainly could be something like scripts or Terraform or another set of capabilities to facilitate it. But one of the challenges is how do I stitch together all of these different constructs and components in a seamless fashion? And so in this particular case, that's where Morpheus really shines to be able to facilitate that process. So in our particular example, what we want to do is initially provision the virtual machine, in this example, in my VMware vSphere environment. Could be Nutanix, could be OpenStack, could be even the public cloud that I want to facilitate this given deployment into. And so after I've provisioned the virtual machine, what I want to do now is then install the requisite components to facilitate our end goal or our solution. So installing the PostgreSQL database, installing the HashiCorp console agent along with the proxy. And so being able to easily deploy those particular components, apply the appropriate configuration. So doing things like specifying what type of service that HashiCorp console should expect, being able to easily stitch that together. Then once those things are deployed, being able to do things like interact with a HashiCorp console to create the appropriate, what are known as intentions, effectively creating the appropriate network rules or level of access to specify that I only want this particular Golang application or this particular application to access this particular database, and utilizing platform like Morpheus, I can facilitate that operation in a number of ways, whether it be utilizing Terraform or utilizing a Python script or utilizing another Ansible playbook to perform that particular configuration. I can then utilize the capabilities of HashiCorp Vault to ensure that the integration from a dynamic database credential standpoint has been facilitated. So reaching out to HashiCorp Vault, configuring the database entry into HashiCorp Vault to let Vault know the information, the credentials it should use to interact with the database, as well as things like setting up roles and appropriate permissions can be facilitated as part of the orchestration and need to be facilitated. And so certainly a number of different moving parts that need to all be stitched together in a seamless fashion to provide that rich, robust experience as though it were similar to the experience that Kubernetes users would get utilizing many of the out-of-the-box capabilities. And so utilizing those two capabilities, we start to stitch together Kubernetes workloads and non-Kubernetes workloads, utilizing many of the same paradigms and many of the same ways in which we operate. And so that reduces administrative overhead. It provides really good alignment in terms of no matter whether the workload is running in Kubernetes or on a virtual machine or on an EC2 instance or on bare metal, I'm getting many of the same management benefits from a unified standpoint to take advantage of the constructs and the benefits we get from Service Mesh, that we get from HashiCorp Vault, and be able to continue to move the quote unquote legacy workloads forward, or the systems that are going to be around for some time in the future, and really continue to provide additional value and really modernize those systems that are typically termed as now legacy, given many of the cloud native capabilities and the Kubernetes paradigms that we're seeing more and more. And so one of the things I want to talk about really briefly is I mentioned where the Morpheus platform fits into what we saw from a solution standpoint. So a number of additional tidbits about the Morpheus platform. It is a self-service hybrid cloud management platform specifically targeted towards or geared for enterprise platform engineering teams. Also is a platform that really helps those that are the more traditional IT operations teams. Certainly a capability that it unlocks and reduces the friction in organizations of enterprise size where pockets of the organization are ready to move really fast and they're waiting on IT resources to be provisioned and spun up. And Morpheus is a platform that unlocks that capability to quickly spin up workloads, utilizing production best practices in on-prem as well as public cloud environments, utilizing the platform for automation and orchestration. So being able to integrate or utilize, as we saw in the example, things like Ansible, things like Python scripts to stitch together the workloads that we saw from a virtual machine or bare metal perspective with those Kubernetes workloads, but also be able to define the Kubernetes workloads in the platform and deploy all of the integration, or in this case, the entire application, utilizing a single piece of capability. And then finally, cost management and reporting from a platform perspective. There's a number of ways to find out more about Morpheus. So certainly we've got some folks there in person that you can chat with and find out more about the platform. We do have a community forum recently announced, discuss.morpheusdata.com. And there is a community edition to kick the tires with, also utilize in your own home lab to interact and interface and stitch things together from a capability standpoint. So certainly open to any questions that any of you all might have regarding what we walked through in this particular session. We'll see how challenging it's going to be, given that I am remote, but we'll give it a shot.
All right, thanks, Matej. So if there's any questions, you have to come over here since the microphone is here. So please, if you have any questions, anyone? All right, so how easy is it to get started? Can I just try this on my laptop?
Yeah, so it is in Morpheus platform is installable on a Linux distribution. So I run it from Vagrant. I run it in EC2 instance in a virtual machine. It takes a matter of minutes. So 10, 15 minutes, the platform is installed, ready to go. And then you simply utilize our codeless integrations to integrate with public clouds or private clouds. So attach it to AWS utilizing just credentials, attach it to VMware vSphere, and then get going with the various integrations. There's Terraform integration for those that like to use Terraform. So being able to utilize it to trigger the execution of Terraform in a self-service fashion. Integration with Kubernetes to be able to manage multiple Kubernetes clusters from a visibility standpoint. So whether it's public cloud Kubernetes or you want to deploy your own flavor of K3S in a VMware vSphere environment, the platform offers a number of capabilities to get going. And you can get started with the Community Edition by registering at morpheushub.com.
All right, thank you. I'm still with Morpheus Terraform. Do you hear him?
I heard Terraform. That was the part I heard.
Okay, can you come up please? He's wondering what is the main difference between your platform and Ansible?
Difference between our platform and Ansible. So the difference between the platform and Ansible, if I heard the question correctly, is that Morpheus can leverage Ansible to actually perform the automation. So Morpheus interacts with clouds, so public clouds, private clouds, and then can run Ansible as part of the stand-up of a given workload, run it as a day two operation. So from a self-service standpoint, you can log into the Morpheus platform, run a given day two operation. So I want to run an Ansible playbook to clean up log files on my system. I can run it against the system. We also have integrations with Ansible Tower, as well as you can run Python scripts, Bash scripts, PowerShell scripts. So it really becomes a framework for workload management.
Okay, so when you, like most of our applications are using Cloud Build and the deployment tools, but is it also a deployment tool or is it just more managing something that's already running?
So it can be used as a provisioning tool, I'll say, used for workload provisioning. So being able to manage day two operations for things like EC2 instances, virtual machines. So really being able to provide a self-service capability for oftentimes developers interacting with IT infrastructure. So oftentimes it's the case of where organizations don't want to give access to the underlying AWS environment or GCP environment or vSphere environment. And Morpheus provides a layer, an abstraction layer on top to enable that self-service management, where as a developer, I could go in and say, you know what, I need to restart this EC2 instance, or I want to run an Ansible playbook against this EC2 instance and alleviate that capability.
So does it have infrastructure as code type of capability then? Or is it still console driven is what I'm trying to do.
Yeah, so it's a great question. So there's a Terraform provider for Morpheus. There's also an API and CLI for those that I want to hit Morpheus. I love its benefits, I love its capabilities, but I just want to integrate it on the tail end of a CI/CD pipeline or run it from my laptop. Absolutely.
Yeah. Okay. Thank you.
Yep. Great questions.
All right, thanks. My own understanding is, when you're trying to do these things yourself, in reality, they're quite complex. So the way I see his description is that this platform can help you kind of integrate everything together. Of course, if you go to the public cloud, they have everything kind of integrated together. But maybe their platform is more like a kind of a platform that helps you with both, on-premises and the cloud. So maybe you have this GUI, and you can do everything from there with all the security being integrated together like he showed us at the beginning. So it looks like a powerful platform that can actually help you with your workload deployment.
One of the use cases is we have some colleges, there's a couple colleges in California where they're using the Morpheus platform to allow their professors to go and provision different labs for different, so if you look at that from their standpoint, they said, okay, well, it's easier for us to have the professors to go and provision that versus having a developer end user trying to figure out how to get the professor to be more of a self-service entity. So that's kind of one of the big use cases. There's a pharmaceutical company that has, one of our larger customers in the UK where they have, they're working on vaccines and whatnot. So they need their scientists to be able to go out and provision, you know, a 16-tier app, you know, out their infrastructure. Well, they don't know how to consume a Terraform infrastructure. They don't know how to do any of that side of things. So the developers and their infrastructure IT folks are setting up that automation in Morpheus and then handing that over to them, making them go and provision and do lifecycle management, doing cost control, those kind of things. Now, instead of a 6-week lead time to get the application deployed, they're now down to about 30 minutes to get that whole infrastructure out. And now the IT staff developers are focused on the .next, and they're giving that control over the end user and saying, here, go do whatever the hell you need to do. We'll focus on what's next and get that prep for you and build more automation around it. So that's really kind of one of the big use cases that I'm seeing attached from my customer standpoint is, you know, how do we enable the end users to start provisioning things and give them that cloud-like experience that the developers are already kind of familiar with, and then put some governance and controls around that kind of, you know, controls from that cost. That's probably pretty wide. That kind of helps.
All right, thanks so much. So I think with this, we can round up the first presentation and then move on to the second. So. All right, so let me the second presenter.
And we do have some flag over here for the backpacks. I don't know if you guys are Karate Kid thing. Part of it. Yeah. So there is some. We do some of our stickers are based off of different movies and whatnot. There's some other stickers over here. Some people have seen the Cobra Kai logo, so I'm just making sure that I will. Oh yeah, easy side. On many times.
All right, thanks, Eric. All right, Matthias, if you want, you can hang on. Otherwise, that will be the end of your presentation. Thanks so much. And now I'm going to bring you the second speaker.
All right, thanks for having me.
All right, so our second presentation is from Grafana Lab, and his name is Michael, and he will introduce himself, and then he and his colleagues will do the presentation. So let's.
I'll definitely take that.
I love fluff.
Was that example? I can remember right now. Reach out to me tomorrow. Hey, speaking of swag, if anybody's interested in a Grafana t-shirt, you're supposed to have supply chain issues, whatever. So if you just want to leave your name and email and t-shirt size, we'll reach out to you and make sure we get you one. And we have the Morpheus folks are just making us look bad. We have one backpack that we have available. We can grab multiple. Yeah,
Yeah,
wider selection.
they're not ready yet, so why not?
Okay. Hi everyone. I'm Jack. I'm one of the organizers for the DevOps Days Davos. We're gonna have an in-person event in August 24th, 26th, and the tickets on sale right now. If you guys are interested, go to the website and take a look at it.
Right, thank you.
Where's it gonna be?
It's gonna be planned on August 24th and 26th.
Yeah, you know, where specifically?
Planned and Denver.
Oh.
It's the same that we did 2 years ago.
I was at it a few years ago.
A few years ago. The previous one was in September. different one, but we still use the same file.
I went to one at the Sunny Event Center.
Yeah,
But it was,
it was huge, like almost 600 people.
yeah. What's the name of the event?
DevOps Day.
DevOps Day.
DevOps Day.
So send me the link and I can.
Yeah, and I have a coupon code for you guys, in the $50 off. I'll write it down so you guys can use the coupon code to,
There are some people watching online as well, so if you want, you can email
just let me
it.
know, I'll write down for you guys somewhere.
Yeah, I can email it.
Email to the group, okay. Cool. Yeah. It's $50 off, $50 off. Get the early bird and then one code is another $50
Okay, I need to
off.
have the presentation as well.
This anniversary.
And if you guys like to,